Hello students, we are going to start surface integrals. In the last class we have seen surface area, so the idea is more or less the same. So this setup is like this. You have x-axis, y-axis and z-axis, and you have a surface. This is your surface given by s f of x comma y comma z equal to a constant, and suppose that this is the shadow region in the xy plane. That means you apply a torch from here. So these are light rays, and look at the shadow region R. And suppose you have a real valued function g defined over this surface g. This is the real line. So from R3 to R, or from S to R, you have the mapping G. From S to the real line, you have this R is the real line R, and this R is the shadow region. You have to distinguish between this R and this R. This R is the shadow region and this R is the real line. The surface integral of G, and assume that G is continuous. The surface integral of G over the surface S is a level surface given by f of x comma y comma z equal to a constant c is defined as or computed, or can be computed as double integral over the shadow region R g of x comma y comma z. G is a function of three variables because it is defined over the surface S into norm of del f divided by norm of del f dot k dA. So this is the double integral. As the double integral dA, and you call this quantity as d sigma. So this d sigma is called the surface area differential, because this much quantity computes the elementary surface area of this surface S. For example, if you take a small portion over the surface, so area of this portion is d sigma. Area of the whole portion is obtained by double integral over R norm of del f divided by norm of del f dot k dA, which is the surface area of S. So that means while computing the surface area, you take G to be equal to this G to be equal to identically equal to one function. Alright, for computing surface area, and for computing the surface integral of an arbitrary function g, what you do is you compute double integral over r g of x y z into this d sigma. So this is notation for this is notation. This is how to compute. This formula says how to compute. Now notation is this double integral. No, this is the surface integral, not the double integral. G d sigma. This is the notation. So this, if you find double integral over S, it's not double integral, it is actually surface integral. Surface integral. And if you find double integral over R, it is actually double integral. And here you have dA comes. When R comes here and dA comes here, then it is a double integral. And when S comes here and d sigma comes here, it is surface integral. So the surface integral can be computed as this double integral. So notation for this quantity is equal to. So surface integral can be computed as a double integral. Now what about the vector k? Vector k is a vector perpendicular to the shadow region. So this is vector k. And in this figure, vector k can be I should write vector p here. What is vector p? Vector p is a vector perpendicular to the shadow region. And if I am projecting the surface S by applying a torch here just vertically above the surface S, then the shadow region R is in the xy plane, and a vector, unit vector perpendicular to this shadow region can be taken as p equal to k. The vector 0, 0, 1. In this figure, p equal to k. In this figure, p equal to k. If I am applying a torch here, this is my torch, then the shadow will be on the xz plane. So in that case, a vector perpendicular to the shadow region is the vector j. That means the vector 0, 1, 0. Likewise, we will do example in the next video. Thank you.